Alright, guys, this is video E4.p1-4. We are still looking at learning target, or we're starting to look at E4.p1b. Analyze the flow of water between the elements of a watershed, including surface features, so lakes, streams, rivers, wetlands, and groundwater. We'll dive much deeper into groundwater and actually what exactly a watershed is a little bit later. So we're going to look at these surface features. And you can see here some fill in the blank stuff. I got a picture of each one and all that, but this is going to be a relatively quick hitter. So without further ado, we'll dive into this. Alright, so surface water systems, features found on Earth that helps to transport precipitation, rain, in streams, lakes, wetlands, rivers, and reservoirs. So, a lake is where surface water runoff has accumulated or built up in a low spot on Earth's surface relative to whatever is around it. Okay, it can still be higher than ground a few miles away, but if it's the lowest spot in that immediate area, we're going to get some collection there. So it's not that the water that forms lakes gets trapped, but the water in a lake comes in faster than it can escape. Most lakes actually have a stream or a river running in and out of it, but it's just the idea that it's pulling up faster than it does get out. There are no rooted plants at the bottoms of lakes, so now we're sort of distinguishing between lakes and ponds because the water's too deep for sunlight to reach the bottom. So therefore, no rooted plants at the very bottom of that lake. Now you're going to have them around the edges maybe, you know, where you're going to have some seaweeds and things like that because sun can get to the bottom, but generally a lake is classified as something deep enough where there's no rooted plants at the bottom. Lakes get their water from precipitation, or rivers and streams, and or from underground water. If you've ever heard of a spring-fed lake, that is a lake, and they're generally very cold, that gets its water from the ground. Ponds are called ponds because they're smaller and shallower than a lake. They have plants growing on the bottom all the way from one side to the other because they are shallow. Most ponds are less than 6 or 7 feet deep. And it says plants need sunlight to grow, and lakes are usually too deep in the middle for plants to grow on the bottom. The temperature of the water in a pond is usually all about the same from top to bottom, whereas in a lake you're going to get to a point where the sun doesn't reach anymore, and that's called a thermocline. You're going to have a pretty quick decrease in the temperature of that water from there on down. But in ponds, they're shallow, so it's relatively the same, and it changes with air temp. So when air temp gets cold, the pond's going to cool off. When it warms up, the pond will warm up. In really cold places, it says ponds can freeze solid top to bottom. It would have to be awfully cold, or I guess a really shallow pond for this to occur in. Rivers. Really, it's just water finding its way off of the land to the lowest point. Okay, so moving from high altitude to low altitude. Elevation. Should be elevation. Higher elevation to lower elevation. All due to gravity. Okay, and you see this picture here of this, whoops, of this really nice meandering river through here. It looks like here we have a meander was cut off, unless it does come back here like this. Almost looks like this one was cut off and could form or was at one point an oxbow lake. But higher elevation to lower elevation because of gravity. Streams, simply smaller than rivers. That's how we're classifying these things. It could also be called a creek, a brook, a spring, just depending on its size. So streams are smaller than rivers. A reservoir is just man-made. It's a man-made lake because of a dam, generally. It's a water holding place. River water backs up behind the dam, creating some sort of reservoir. Lake Mead, out west. I think that's Nevada. A huge lake, very huge lake, deep lake. It's a reservoir actually because of the dam, Hoover Dam, I believe. So wetlands. says a wetland is land characterized by the presence, it says the presence of water at a frequency and duration sufficient to support, and under normal circumstances does support wetland vegetation or aquatic life. We have different types of wetlands: bogs, swamps, marshes, fens, all different forms because of different plants that are growing there. So a wetland is just an area that has water for the vast majority of the year, if not the entire year. Wetlands cover about 15% of Michigan. There's lots and lots of benefits to wetlands. Unfortunately, we didn't figure this out before we had destroyed much of them. They help stop flooding because they kind of soak up water like a sponge. They stop erosion because there are rooted plants. They clean the water. They sort of filter the water, so they're like nature's kidneys. Recreation and wildlife habitat, lots of fishing or bird watching, whatever. But wetlands are really, really important for these characteristics, especially water quality and flood and erosion control, or attenuation it's called. Nowadays in Michigan, if you're going to develop land, build somewhere, and you're filling in a wetland to create a foundation, you have to create at least that much wetlands. It might be twice as much of an area of wetlands. So if you destroy a square mile of wetlands, you have to create 2 square miles. It's something like that. You can't just go around destroying wetlands because we've realized how very important they are. With that, these notes are finished. We will talk more about wetlands here to come in E4.p1-4.